Unfortunately, Martin couldn't make it to Göttingen this year, so he will join us remotely here from down under. And Martin is going to talk about the CTDB Report 2026. Welcome, Martin.
Thank you, thank you. There it is. Okay, yep, I'm Martin. I'm a member of the Samba Team. I'm the guy who spends most of his time working on CTDB. And so that's what I'm going to talk about today. Thanks for coming. All right, so what are we going to talk about? First, a quick overview of the plan. Going to talk about progress in CTDB in the past 12 months. Going to see what's in the queue. There've been too many plans that haven't happened, so I've got some very vague plans. And then we can do questions if there are any questions, if there is anyone there. And although this is a development-based talk, you know, hopefully there will be some jokes or something that everyone finds amusing, and that way everyone can get something out of this talk. So there may be a better talk next door. This is your last chance. 3, 2, 1. I don't see anyone leaving. Good, good. Okay, so how does CTDB fit in? CTDB is the clustered trivial database. It's the thing that allows clustered Samba to be clustered. It manages a bunch of TDBs so that SMBD and WinBindD can access them and not think too much about the clustering part. So as I said, it is a database. So it's a clustered database for Samba metadata. There's distributed databases which are really fast to read if you've got the record. They're also really fast to write because you're always writing the record locally. But if there's contention, those databases can be a bit slow. It also handles replicated databases, which are the same on every node in the cluster. So all the SMBDs, for example, see the same content. And those databases are quite slow because they have to make sure data is written to disk in a persistent way before they say, yep, done. Apart from that, CTDB provides a cluster-wide messaging transport for Samba. It does cluster management. There's a leader elected, and all the other nodes are members of the cluster. It also handles dynamic IP address failover. CTDB calls them public IP addresses. Other people might call them virtual IPs or something similar. The other thing is that CTDB manages the services that provide, file data and such to clients. So it starts, monitors, and stops the various daemons. All right, so that's a brief introduction for those who don't know CTDB. Now, what have we done in the last 12 months? There have been over 100 commits. I seem to be the last person standing. But there are a bunch of other people who've made contributions, and we'll cover them as we go. So, who reviews the commits? Reviewers are really important. So, this is the group of heroes who have come in and reviewed all of the CTDB patches. And Anup has done an outstanding job there. John recently picked up a series that I thought nobody was going to review, and did a really quick job of reviewing that. That was really nice. Amate, he's pretty busy. I try not to hassle him. He says hassle me, but I don't want to bug him too much. Speaking of reviewers, in the last 12 months, these are the reviewers for all of Samba. And Anoop has come from nowhere and absolutely rocks. So applause, please, for Anoop. Fantastic. There are many more reviewers, but there's not enough space here. So yeah, but I just wanted to call out Anoop's amazing review record for the past 12 months. Okay, what are the main areas where we've made progress? And I'll go through them one at a time because that's the main focus of the talk. So failover and shutdown, a nice way of loading more tunables files, something that might be considered a security fix, something cool for Prometheus, some NFS v3 SM notify issues, JSON support for CTDB status output, just the beginning. CTDB used to have lots of helper environment variables, and there are now there's now basically one that's used to locate all of the helpers because they all live in the same place. And also, I think support for public IP addresses on interface alt names is now complete. So details, everyone wants details. So here's a little problem. So we have two clients, A and B, talking to two different nodes in the cluster, both trying to get locks on file F via NFS. So A currently has a lock. B wants to take a conflicting lock. So now we shut down CTDB on node X. The first thing that happens is all the public IP addresses are released. Then the NFS server is stopped. And as soon as that NFS server is stopped, the lock on F is released on node X. And that's a lock in the cluster file system. So then the NFS server on node Y says, yeah, beauty, I can take the lock on F, and then it grants that lock to client B. Meanwhile, another node notices that X is down, starts failover. Address P is assigned to node Z, could be Y, depends how many nodes there are and where it ends up. Then client A attempts to reclaim the lock on F via NFS server on node Z. Lock reclaim fails because it's already held by client B in the file system. However, the application on client A still thinks it has the lock. There's no way to tell a client that it doesn't have, say, a byte range lock. So then applications on A and B both modify the contended range in F, and hilarity ensues. Bad things happen, not hilarity. So we get file corruption probably. So what we need to do, what we used to do, is simply release the IPs, shut down NFS. However, we decided we needed to initiate failover before shutdown completes, and that triggers NFS grace. We also add a configurable timeout between failover and then continuing shutdown. That helps for the next point. Ralph Boomer requested something similar to this 5 years ago for SMB durable file handles. He was doing it in a very different way, and we said, yeah, we're getting rid of that thing. We can't really do this. But the failover is for that purpose, so to give other clients the chance to come and reclaim that state. A note for later. This fix adds a nested event loop, and nested event loops are really cool, and they result in systems that are incredibly easy to reason about if, yes, anyway. So that's that one. Okay, So tunables. Tunables are things I'd love to get rid of in CTDB. They're numerical values that you can set at runtime. At startup, they're historically set from a file, like etc. CTDB tunables, depending on compile type configuration. However, as a vendor, I want to put settings in my own file and not expose that to the customer. And I still want to allow the customer admins to add settings elsewhere if they really need to. So, and the particular example here was that within a long-term support release, we are offering NFS-only online upgrade in our product, and that means we have to tell CTDB not to be so strict about version checking, so there's a tunable we can set there. So all of this is to be able to set one tunable and not allow the customer admin to unset it. So how can we add more config files? Well, we can add include files, but then we have to consider, are we going to allow wildcards? And if we just want to allow a directory full of files, say, then wildcards are cool. How deep should we allow include files? Just one level? Or should we allow deeper nesting of includes? Then we have to implement loop detection. It gets ugly. So I had a look around at what the trend seems to be, and I noticed that sysctl used to have etc. sysctl.conf. It now doesn't, and it used to have the .d directory, but it implemented it via includes. However, that's changed, and now there's just a .d directory. modprobe.d is similar. So the same thing to do is to just load all the files with some suffix that live in a directory, and it's a safe, well-defined approach. So now we can have vendor variables in one file and expose another to the customer if that's what we want to do. I'm glancing around and seeing if anyone has their hand up or anything. I don't know how I would tell that anyway, so let's continue. So CTDB uses environment variables to set up its test environment. And this is a choice that's made to not expose the test mechanism to, and actually generally not documented, because we don't want to stick things in documentation and have foolish people setting test variables and putting things into test mode. However, we used to respect the CTDB socket variable, and somebody reported a security issue where we used chown and chmod on the value that we get from that variable. And, this can cause security issues with symlink races and whatever. So the obvious thing is to say, well, why do we need this variable? Let's remove it. And, you do a git grep and you find, well, no, it's used in the clustered member test environment, so we can't just remove it. And the reporter says you should use fchown. Well, unfortunately, that may be supported in Linux on sockets, can't remember, but it's generally not portably supported on sockets. So let's not do that either. So the idea here is you limit CTDB socket and you only use it if CTDB test mode is set. And then you, in the README files for developers and whoever else, you document that CTDB test mode is only for testing and should never be used in production. And hopefully everyone listens and you end up with something sensible. So yes, I think that's kind of a security report that wasn't. It wasn't that interesting, and CTDB socket was never documented, so nobody should have been using it in production anyway. Next, Okay, so there was a request from, well, Ralph used a setting, an internal setting in the CTDB Prometheus exporter that he wrote, and it caused continuation after script failure, which he didn't realize. He thought it was doing, it would just return the event status for all the scripts, but it turns out that it would continue after failure, and if one script depended upon previous ones, then they may not work because of the previous failures. So what he really wanted was for CTDB's API to return the event status for all scripts that were run in for a particular event, even those not run in the latest iteration. So, you know, say this time you ran down to 50.samba and 60.nfs didn't get run. Well, Ralph wants to know that 60.nfs ran 15 seconds ago and passed. So the idea there is update a bit of plumbing. The relevant control or internal API now returns all events, all scripts, I should say, that's a typo, all scripts for the event. And the important thing is that the CTDB event status command is unchanged. We wanted to change the internal API so that the Prometheus exporter could get its hands on all the data. However, CTDB event status shouldn't change. It only shows scripts from the most recent iteration. The slight hack in there is that it stops when the timestamp in the result list goes backwards. Hopefully NTP is pretty sane and doesn't throw the time backwards exactly when somebody's, or backwards too far when somebody's running CTDB event status. So, but you have to pick your battles there, and that seemed like a good compromise. Nobody's waving. No. All right. We had a couple of NFS SM notify issues in our NFS v3 glue. The first was new and was fairly simple. For lots of years, we've had one script called SM notify that handles events from rpc.statd and also handles the internal events that occur on failover that are generated by CTDB. A few years ago, many years ago, we did something stupid. We applied the quickest hack we could think of when Red Hat distros started running statd as RPC user instead of as root. And our script could no longer talk to CTDB on the socket. So we just made the script sudo itself if it was running as non-root. You then start to do some performance analysis and you find, well, okay, that's making the script twice as slow and introducing a lot of latency. And can we make the script faster? No. So what I ended up doing was splitting it out into a separate statd callout.c program. And I very diligently made sure that it only handled known arguments and printed a usage message when it got the ones that I hadn't planned for. The dumb thing there is that I didn't handle SM notify. And when we decided that we should implement SM notify forwarding between nodes, things didn't go smoothly when SM notify started generating a usage message. So we looked at the old script. It used to fail open. It just silently ignored unknown commands passed to it. So the fix was pretty dumb, pretty simple. Just add no op handling for the SM notify command when it gets passed to SM notify by rpc.statd. The forwarding we have not upstreamed yet because it could be slightly neater. So that will come. That will come. That's one of very few patches that we are currently carrying. The other thing is a day one problem. If you're using CTDB with NFS and you're using the old statd call out and the way that it would store notification records in a database on disk, there's a complication where the call out doesn't know the address that the public IP address that the client has connected to and has taken a lock against. So it actually creates a record for all public IP addresses currently held. They move around a bit. And then sometime later, we would send out notifications for all public IP addresses held by the current node, rather than the ones that had just moved to it. And that meant that we expunged too many records from the notification database, and the records got lost. And then later on, we didn't recover locks that we should have recovered. And the fix is just to notify only from public IP addresses that have moved, and fixes by my big brother Peter, who's been working with us for about 1.5 years. JSON support. Suggestions to do this have been around for a while. CTDB originally used these colon separated fields on a line. Then we decided we had to support IPv6, and the colons didn't work. Well, they would have worked, but it would have been more difficult to parse. So we changed it to pipes, and we still have this homegrown machine-readable format. But now John has come along and implemented the -J or --JSON option for CTDB status, and you get fancy status output. There's also CTDB version -J, and from that you can tell, does this version support JSON output? Like, it might give a usage message. If it doesn't, can't actually remember for sure. But if CTDB version -J doesn't return JSON, then you know that you're using an old version or you haven't compiled in JSON support. It's still optional. The nice thing about the way he's done it compared to the old machine-readable nonsense is that it gives an error for commands not supporting the JSON option. So JSON comes to CTDB, and I think this is just the beginning. So thanks to John and Shaka, I think his name is pronounced, for their contribution there. How are we doing for time? We've got plenty of time. We're going to finish early. This is going to be great. So earlier on, we got rid of CTDB socket, and partly for this statd call out forwarding, this SM notify forwarding, I started looking at the number of helper variables in CTDB, and CTDB has lots of helper programs. There's a lock helper, there's there are lots. And we had one environment variable per helper, and that was 8, 9, something like that. And they also weren't covered by CTDB test mode. So, you know, there's a chance that if somebody was able to set a bogus environment variable on somebody's machine, then they could run something unexpected. You know, to do that, you've got to be root. To run CTDB, you've got to be root. I guess they've got bigger problems if somebody can do this sort of thing. But hey, let's neaten it up for the future. So added a single variable, CTDB test helper binder, one variable to rule them all, and it's covered by CTDB test mode. And, you know, through a sequence of, 15 or so commits, shifted over to this model where we can now find all the helpers, or nearly all of them, in that directory. And if we ever do, come up with CTDB process D, which is an idea I mentioned last year and I'm not going to mention later in the talk this year. If you want to run a helper, you can say run a helper and just give the short name for it, and it can be run out of the helper directory, or if we're in test mode and CTDB test helper binder is set, then we know where we can find the helper programs, if we're running in tree or whatever. So, it's a cleanup and it's a step for the future. So I thought this was a good one. So, supporting public IP addresses on interface alt names. I hadn't really noticed alt names before, but if you type IP link on a machine, probably with, it's ironic. I wonder if Network Manager creates these alt names. I don't think it's UDEV, but I guess it could be. I think UDEV just does the underlying naming. But anyway, in our product, we run CTDB with a centralized configuration, which means we use the same public addresses file on all nodes. However, if somebody has a failed node and wants to add a new node or replace a node or add a new node, and the hardware is a bit different, the interface names might be different. So what are you going to do? Well, you can use UDEV rules, but I've always found that to be trickier than I think it should be. So I thought, well, what if we provided a way to add alt names as an alternative name for the interface? And these are very easy to add. You just do it like that. And this works for all sorts of IP commands where you say dev eth0, in this case, is the alt name. And it also works when you use if name to index in code. So the CTDB change is nice and easy to see if an interface exists. Just run if name to index, call if name to index. If it returns non-zero, your interface exists. Various methods of listing interfaces don't really do that. They only include the primary name unless it's buried somewhere where I couldn't find it. So in code like that, where you want to search through interfaces, you use name to index to get the index and then match on index. So it's not too gross. It's quite nice. The script changes for release IP and update IP, they were a little harder because there are a bunch of assumptions built into the script. And one thing is that you can't post-match an interface name when working with an alt name. So say I'm trying to figure out which interface that address ending in 123 is on, I can use IP brief address show to that. And it says it's on this interface, which is the primary or real name, and there's no clue of the alt name there. So then what the scripts were doing is they were doing that sort of lookup that you see there, getting the interface name and saying, whoa, the address isn't on eth0, it's on enp0, blah, blah, blah. And it would log a warning. And now that's annoying because I thought I'd fixed it in the C code. But as soon as I tried it and did a failover, I noticed the warning being logged. So a little series of, 15 or so commits. And the number of bugs and atrocities I found in my own scripting from days gone by was shocking. But the key here is that as long as you put the device in your lookup, then you'll get output. If 123 isn't on an interface called eth0 or with alt name eth0, then you won't get any output from that IP command. So if you get output, even though the interface name is different, you know that eth0 matched. So that's pretty cool. We are down to, that's half an hour in. Miscellaneous changes. A bunch of things that I won't spend a lot of time on. There are symbolic names basically symbolic names for ports. CTDB can automatically monitor ports, but it needs the number. So Meta added some scripting code to normalize the transports to TCP ports. Alexander and Andreas fixed the PCP PMDA build with newer versions. I think it was 7.0.0. Volker found a case where if a leader broadcast got delayed, you would go into election and get stuck forever. So that was good to fix. Somebody reported a crash with the update IP thing, which I've always described as poor man's bonding, where you can have an address on one of a number of interfaces on each machine, and it will fail over between them. I'm constantly surprised that people use this, but somebody reported a bug. You know how I said before nested event loops are cool? Man, oh man. I added the nested event loop for failover on shutdown, and it could have only been a month later. Volker came along and said, I'm seeing this problem, and I think it's because of your new nested event loop, and I think this is the solution. And I said, yes, that's the solution, but you need a big comment. But yeah, more proof that having a single event loop and doing things in a very structured way means that you're a lot less likely to get these weirdnesses where you get unexpected things happening. While adding some feature, it's host monitoring, which is on about the next slide. I decided it might as well be portable, and I tested on FreeBSD and found out that we'd broken it years ago and it didn't even build, so I fixed the build and I fixed a bunch of things. Also lots of script cleanups, formatting, shell checking, and fixing of stupid things, nearly all done by me in the past. What's in the queue? I've got a couple of open merge requests sitting there. One's been there for a couple of months, and back in 2023, Meta fixed a crash in CTDB that was related to multi-channel and how connections are handed over. But this causes connections to be removed from our tracking when the client disconnects. And that means the takeover node can't send out tickle-acks and things. I only noticed this year when I finally got auto cluster running reliably again and ran the cluster tests, and one test reliably failed. So I opened a merge request, and hopefully it gets fixed soon. The other thing is that it's always DNS, right? The hardest things I've ever had to work on have been generic networking problems where the network has become unreliable and things have become unexpectedly disconnected. That's the hardest. The second hardest has been DNS has gone away. The customer has left our resolve.conf as is on our nodes, but they've decommissioned DNS servers, or maybe they decommissioned one, another one is down, you start to get DNS timeouts. We saw that years ago at a customer who swore their DNS was rock solid. When we were running kernel NFS and the NFS server was starting and it was checking, it was looking up host names in there at startup time, I think, to figure out the corresponding IP addresses. And so therefore startup would hang. And it took a lot of time to discover that this was a DNS problem. The 50.samba monitoring used to do some really stupid stuff with test palm and reparse itself and produce options that we really weren't interested in, including some that required DNS lookups. And about 3 or 4 years ago at a customer, we were seeing weird failures and we tracked them down to DNS. More recently, we had another customer where AD discovery and AD connection was timing out, DNS. So 3 years ago, with the monitoring bug, I wrote some host monitoring for CTDB. We fixed it another way so the DNS lookups weren't done. So I shelved this. But now after the AD disaster, I've pulled it out, and this has got some quite neat monitoring for all the DNS servers listed in resolve.conf. You can give it a host name, which could be the domain if that's lookupable in DNS. And CTDB will, by default, if you configure it the simplest way, there's good documentation for it in this merge request. It'll warn once the first time the DNS server goes away, and then it'll warn every hour approximately, so that if the DNS server goes away 3 months ago and the customer reports a fault now because a second DNS server has suddenly gone down, you can see that the other DNS server has been missing every hour since your log started. So centralized monitoring is wonderful. Lots of people have centralized monitoring. Wouldn't have helped in this case because our resolve.conf on our nodes wasn't updated and was still pointing to decommissioned DNS servers. So, yep. So I think it's a useful feature. Hopefully somebody else does too. It's just a bunch of scripting. Coming soon. Around the time I joined DDM, I think a little before, Vineet wrote some IPv4 up, sending code for IP over InfiniBand. It wasn't brilliantly integrated into the rest of the code, so I've been meaning to do that, and we're hoping to support IPv6, including IPv6 on IP over InfiniBand sometime soon. Which means I've reworked the existing code and taken the logic out of Vineet's patch, and I have something working for IPv4 ARP, which ends up being the same code, the same logic that he was using in his patch. So he has a signed off by on that patch. A couple of the patches in that series. I'm still trying to figure out how to construct the link layer multicast address for IPv6 neighbor advertisements. I don't quite know how to do that, but I'll get there. We have 5 minutes to go. I'm nearly done. While testing persistent handles with CTDB stop, Ralph noticed it was slow. I've had this patch for a few years because I noticed that we should be able to speed it up. The leader node should just be able to send out an unknown leader broadcast to say, I can't be leader, I'm done here. Election starts straight away, you get a new leader straight away. I've got to figure out why it doesn't work and get it into the code. Plans for the future. Not many. I still want to do the magic rewrite, but I won't talk too much about it. In the past 12 months, I've taken Amadeus next generation transport daemon. I fixed some bugs. It builds and runs. Internode TCP connectivity isn't implemented. He never got to it. So I'll write some tests for local connectivity. I'll add TCP connectivity and tweak the client code that he has there so that new protocol can be tunneled through current CTDBD and we can migrate. Is the future JSON? We have JSON in CTDB now. for various reasons, I have a CTDB implementation, and I wrote some tests using a JSON data format for input and output for the tests. When I went looking for a good JSON protocol, I found JSON RPC. It rocks. It's simple, symmetric, elegant. So I wrote a T-event rec-based JSON RPC server-side computation. I wrote some test code for it and just piped JSON into it and checked the JSON that comes out of it. I rewrote my CTDB test code using it and as proof of concept, and it works nicely. And all of our protocols have like method numbers, if you like, you know, and we assign names to them, 1, 2, 3, 4, 5. Well, I kind of think that this could be protocol element 0. If somebody passes 0 for the control or whatever that they want a CTDB to do, then it just gets passed to a JSON RPC computation and returns JSON RPC result or error. I think it'd be cool. That's all I got. Is there anyone still there? Is anyone still alive? Is there anybody alive out there?